Today we are going to tackle the unit circle, which is something that a lot of people are really scared of, and most people try to approach it with memorization, which can work if you work at it enough times, but I'm going to break it down. I'm actually going to create the unit circle so you can see where all of these crazy numbers and radians and degrees come from, and hopefully that'll help you remember it, because it's something that's really, really important to trig, and it's really important in calculus, especially when you get to Calc 2. A lot of professors, well, I guess all professors, are going to expect that you have it memorized, so it's something really important to know. So before we talk about the unit circle itself, we need to take a trip back to high school and talk about special triangles. And if you're anything like me, you forgot about these the second you walk out of your Algebra 2 classroom, because when do you ever use them? But we've got the 45-45 90-degree triangle and the 30-60 90-degree triangle. And these triangles are really going to be the building blocks of our unit circle. So they're called special triangles because any triangle with these measurements is always going to have these side lengths. So for the 45-45 90, it's always going to be x for the two legs and x times the square root of 2 for the hypotenuse, whereas the 30-60 90 triangle, the side opposite of 30 is going to have x, the side opposite of 60 is going to have square root of 3 times x, and the hypotenuse is going to be 2x. Now, when we talk about unit circle, that word unit means 1. So we've got a circle, and the radius is going to be 1 unit. So what we need to do is, if you think about it, so if we've got a circle here, and our unit circle takes place on the coordinate grid, so pretend that's in the middle, it's totally not, but we're going to have a bunch of triangles that come out from the origin, and that's how it's going to be built. So all of these hypotenuses, hypoteni? I don't know, but they all have to be the same length as they all have to be the radius of the circle, so they all have to be 1. So what we're going to do is we want to make it so that the hypotenuse of each triangle is 1, and then adjust every side accordingly. So starting with the 30-60 90 triangle, our hypotenuse is 2x, so I'm going to divide that by 2 to get it to be 1. So that means that this is divided by 2, and this is divided by 2. So now we just have x as our hypotenuse. We have x over 2 as our short side, and we have square root of 3 times x over 2 as our long side. And you have to remember here that x equals 1. So now when we come over here to the 45-45 90-degree triangle, we're going to divide everything by the square root of 2. And then when we go ahead and we rationalize the denominator, these are going to be, it's going to be square root of 2 over 2. And it's going to cancel out here, and it's going to cancel that out here. So these are our special triangles with the sides that we're going to worry about. So the 45-45 90 is square root of 2 over 2 on either side with a hypotenuse of 1, and the 30-60 90 is square root of 3 over 2 on the long side, 1/2 on the bottom, and 1 on the hypotenuse. So just keep these in the back of your mind because they're going to be really important. So, like I said, the unit circle is drawn on the coordinate grid, so we've got our origin at the middle, and our x-axes and y-axes are going through here. And what's important to remember is that this length is 1. So if we want to go ahead and mark these 4 corner points, this is going to be 1, 0, right? Because you go 1 over on the x-axis and 0 on the y. This is going to be 0, 1. This is -1, 0. And this is 0, -1. Now to figure out what the coordinates are of each of these other notches that are in between our main points, we're going to go ahead and use those special triangles. So let's focus on the middle notches here. I'm going to draw a triangle with the origin with the main angle at the origin. And we've got this here. This is our 45-45-90 triangle. So this is 1, this is square root of 2 over 2, this is square root of 2 over 2. So that becomes our coordinate points for that spot. And that's the same around the triangle at every one of these points. You have to remember your negatives though, so on this side the x is negative. And then down here, we've got both of them negative in quadrant 3. That's a negative sign. And then over here, we've got positive x, negative y. Now let's take a look at these notches that are closest to the x-axis. These we're still going to draw these triangles. And this is going to be our 30, 60, 90 triangle. But what's important to try to figure out here is which way is this triangle facing. This tiny angle is our 30, and this angle right here is our 60. Which means if we're going to translate this triangle, we've got 1 at the hypotenuse, square root of 3 over 2 on the long side, and 1/2 on the short side. So our x is square root of 3, square root of 3 over 2, and our y is 1/2. And then just like we did for the 45-degree triangles, we're going to go through and do this again. So our x is negative over here, and our y is positive. And they're both negative here. And we have a positive x and a negative y. Now let's take a look at the notches that are closest to the y-axis. We're going to draw that triangle again, and this is still our 30, 60, 90 triangle, but we've got the 30-degree angle up here and the 60-degree angle over here, and this is our right angle. So that means that this side is going to be our square root of 3 over 2, this is going to be our 1/2, this is going to be our 1. So with these, our x and our y are switched. Just like that. So now we have figured out where all of the coordinate points of the unit circle come from. And I just saw that. I forgot a parenthesis there. But so that's one piece of the puzzle. Next we're going to take a look at the radians. Radians are exact measures that that use pi in order to figure out where you are on a circle. So a full circle rotation is 2 pi radians. So that means that this is our 0 because it's our starting point, but it's also 2 pi. And 180 degrees, which would be a straight line, is equal to pi. So that means that 90 degrees up here is pi over 2. That's really bad. I will rewrite that. Pi over 2. And down here we have 3 pi over 2. Now let's go ahead and pay attention to these middle notches like we did last time. If we go from 0 to pi over 2 here, and this is the halfway mark, that means that this is pi over 4. And basically each of these marks is going to be one more quarter. So this is going to be, So that's 2 pi over 4, so this will be 3 pi over 4. This is 4 pi over 4, because the 4's will cancel out. So we've got 5 pi over 4 here. 3 pi over 2 is 6 pi over 4. We got 7 pi over 4, and then 2 pi is 8 pi over 4. Now paying attention to these other small notches, everything that I'm going to mark in green is done in increments of pi over 6. So this first one's pi over 6. The second one is 2 pi over 6, which is pi over 3. This one up here is 3 pi over 6, which simplifies to pi over 2. This is 4 pi over 6, which simplifies to 2 pi over 3. We've got 5 pi over 6. 6 pi over 6 here is just pi. 7 pi over 6, 8 pi over 6, 9 pi over 6 simplifies to 3 pi over 2, 10 pi over 6 simplifies to 5 pi over 3, and we've got 11 pi over 6 here. So here we go, we've got our radian measures for the unit circle as well. And now we have to look at our degree measures, which I've kind of hinted at already, but just to be clear, we've got our starting point is 0 degrees, and a full circle is 360. So when we make it back around, this will be 360, and that straight line is 180. So now we have to go between here. So right up here, this is our 90-degree angle, and 180 plus 90 is 270 down here. Now, looking at these middle pieces, this is halfway between 0 and 90, so that's going to be 45 degrees, and it's going to be going around in 45-degree increments every time. So we've got 135 here, 225 here, and 315 here. And now the rest of these are in 30-degree increments. So you got 30, 60, 90 is there, 120, 150, 180 is there, 210, 240, 270 is there, 300, 330, and 360 is already there. So there are our degree measurements. So here's the unit circle with everything we've figured out so far. We've got our coordinate points, which we figured out with our special triangles. We've got our radians, and we've got our degrees. One last important thing to think about is how the trig functions fit into the unit circle. So we've got x and y coordinates because these are happening on the coordinate planes. But this is really cosine and sine. So if you're asked what is the cosine at pi over 6, you can find where pi over 6 is, and that x value is square root of 3 over 2. So the cosine here is square root of 3 over 2. If you were to say, what's the sine at 4 pi over 3, find 4 pi over 3, that y value is negative square root of 3 over 2, there you go, that's your sine. One thing that's important to remember that is tangent is cosine over sine, which means that it's also x over y. I'm sorry, I got that backwards. Tangent is sine over cosine, which means that it's y over x. So, if we want to find the tangent at any of these points, you're going to take the y coordinate and put it over the x coordinate. So, let's take a look at our main points in finding the tangent. Y over x is 0 over 1, so it's going to be undefined here. At the top, that's going to be, I'm sorry, I got that backwards as well. 0 divided by 1 is just 0. At the top here, we've got 1 divided by 0. That's undefined. You're not allowed to divide anything by 0. Over here, we've got 0 divided by negative 1 is just going to be 0. And in the bottom, we've got negative 1 divided by 0, which again is unallowed, or is not allowed, so we've got undefined. Now, let's look at our 45-degree angles. So we've got here, 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 and here. These coordinates are all the same, so when you divide it by each other, you're going to get 1 here. But if you look at it in the quadrant 2 side, it's that divided by the negative of that. So we've got negative 1 here. Negative divided by a negative is positive 1, and then negative divided by a positive is negative 1 there. Now let's look at our 30-degree triangle. So we've got here, 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 and here. We're going to have 1/2 over the square root of 3 over 2. So 1/2 over square root of 3 over 2. Remember, dividing fractions is easy as pie. Just flip the bottom and multiply. So it's going to be over 2 over square root of 3. So these are going to cancel out. We're going to get 1 over square root of 3. But we want to rationalize that denominator, right? So we end up with the square root of 3 over 3 as our tangent. So it's going to be the same at all of these, you just have to consider where your negatives are at. So we've got negative over here, positive over here, and negative over here. Now let's take a look at our 60-degree angles. We are going to have square root of 3 over 2 over 1/2. So flipping that up, we're going to get 2 over 1. So our tangent here is square root of 3. And again, just pay attention to those negatives. And now we have all of our sines, cosines, and tangents labeled, as well as our radians. So the only thing that isn't on here right now is those degrees, but those are easy enough to remember if you want to try. I mean, if you've got 0 degrees here, you've got 180 here, 90 here, 270 here. So each of these slices is 90 degrees. The middle points, the between of 90 is always 45, and then these are going to be 30, 60, 90, 120, 150, 180, so on, going all the way around. So here we have our final unit circle. I drew in the degree measures in red and the tangents in green. Remember that your radians are these pi values listed inside, and for as far as coordinates go, cosine is x, sine is y. I hope that this kind of made sense. You can see where it's coming from. If you want to try to work it out yourself, that might really help you as far as remembering how these things work. And if that doesn't work for you, there is always the old-fashioned memorization route, but either way, this is something that's really important to know, and I recommend that you give it the time to sit down and learn it.